Hello everyone. Today we're going to be talking about isosceles and equilateral triangles. We're skipping around just a little bit. The homework is called 5.2 and is posted in Big Ideas, but this is not technically 5.2. But it is probably the easiest thing that you can do without your notes because it's the most straightforward. So that's why we're hitting equilateral and isosceles triangles right now. Now, if you remember from the other day when we were talking about equilateral triangles, equilateral is a classification of triangle that says all three sides are the same. And that's an equilateral triangle, and so is this equilateral triangle. As long as we're marking all the sides the same, equilateral triangles. Equilateral triangles are also equiangular triangles, which means if all of the sides are the same, all of the angles are also the same. And you'll notice I've marked the sides on this triangle differently than I've marked the sides on this triangle. That's because the sides here are different. But the angles are actually all the same. If you remember from the other day, if you add up all of the internal angles of a triangle, interior I should say, angles of a triangle, you will always get 180 degrees. So this plus this plus this is 180. This plus this plus this is 180. 180 divided by 3, because they have to be the same, means that every single angle I've currently drawn up on my whiteboard right now is 60 degrees. So it does not matter how big the equilateral triangle is, the sides will all be the same, and the angles will all be 60, so keep that in mind. And equilateral and equiangular are one of those things that can go both ways. If you have equilateral triangles, meaning all the sides are the same, then the triangle is also equiangular. If you have an equiangular triangle, meaning all the angles are equal, then it is also an equilateral triangle. So you can always assume that going both directions. So we're going to do just a couple of problems because equilateral and equiangular triangles are pretty straightforward. So you're going to be given some problems today that are going to look like this. Let's go with 12. And let's call this x. And let's say this is what's happening here. Okay? Staring at this triangle, I know all three angles are the same because that's what it means when they've just got the one arc through them. Because it is an equiangular triangle, that means it is also equilateral, which means, again, all of the sides are therefore the same. So if this side is 12 and this side is x, these two have to be the same, and x would equal 12. If I were to have made this slightly more complicated, notice that we just set these equal to each other. To make it just a little bit gross, and let's make this not x, but let's call this 2x plus 4. Because that's more fun. Okay? Process still works out to be exactly the same. We're just going to take these two and we're going to set them equal to each other. 12 equals 2x plus 4, and then we've got to solve for x. Divide by 2. And now x equals 4. Okay? So with an equilateral or equiangular triangle, all the sides are the same. Incidentally, at this point, we should also know what this angle measurement is. 60. Because it's equiangular, they all have to be the same. So let's make this 3y, just for funsies. Okay? If we were to ask you what y is, well, I know this angle is 60 degrees. So 60 equals 3y. You could, if you wanted to, and this would be a gross way to do this, but you could if you wanted to, say, well, this is 3y, therefore this is 3y, therefore this is 3y, therefore 3y plus 3y plus 3y equals 180. You could, and the answer would be the same. It is faster. Divide by 3. You get our y by itself, and 20 equals y. So that's equilateral and equiangular triangles. We also need to talk about isosceles triangles. Give me a second, I'm going to rewrite. Get some music while I'm erasing. Elevator music. Never mind. Alright, anyway. That's on the recording now. Alright, isosceles triangles. We talked about this too. Isosceles is a length classification. And remember when we are classifying triangles by length, what our concern is how many sides are the same. So with an isosceles triangle, we have two sides that are the same. there's a really important theorem that goes with this, and it's called the base angles theorem. You know it's important? Because I'm bothering to write it out. That's a hint that you should also maybe write it down. Okay? The base angles theorem states that if these two sides are congruent to each other, if we have an isosceles triangle, then the base angles of the isosceles triangle are also congruent. And the base angles are the two angles right there. Okay? It is the two angles that are not between my two congruent sides. So these two are also the same. Now, with equilateral and equiangular triangles, I knew the measurements were all 60 because all three are the same. But because this can be anything, well, anything less than 180, I don't have any idea what these are. All I know is that they are the same. So these problems are just a little bit trickier. So if they give you an isosceles triangle, and I don't know, what's that? That's 100? I'm going to say that's 100. I'm going to call that 100. Okay? And I ask for this angle measurement. The solution to this, I know that all three add up to equal 180 degrees. These two are the same. So if this is x and they gave me just an x here, I know this is also x. 100 plus x equals 180 degrees. Again, when you add up all the interior angles of a triangle, you always get 180 degrees. So 100 plus x equals 180. And the reason we know these are both x is because I know they're the same. They only gave me this one, but I know they're the same. Combine our like terms. Subtract 100. And 2x equals 80. X equals 40. So these are both 40-degree angles. And if they make it more complicated and make this 2x, then you're going to add 2x plus 2x, or plus 3x minus 5 plus 3x minus 5. Whatever they give you, you'll just get longer and more complex equations there. A couple more things that I want to show you. Do I have time? Oh, so much time. Elevator music. Alright, the other thing that I want to talk about with isosceles triangles is occasionally they'll give you one that will look like this, and they'll give you, this one's 40. I already did a 40. Don't do 40 again. That's ridiculous. Don't write that down. Give me a different number. 36. That's obscure. Let's say that's 36. And then they will ask you for this angle and for this angle. Okay? And that's all they'll give you. Now, I know this is an isosceles triangle, which means this angle and this angle are congruent. So y is easy. Y is 36 because it has to be the same as the other base angle of our isosceles triangle. Oh, another way to think about, like, try and remember in your brain thoughts, which angles are congruent. These two sides are congruent, therefore their opposite two angles are congruent, if that helps. Because sometimes, like, I'm going to twist the isosceles triangle on you. Just another way to think about that. So I know I've got two angles that are 36. Again, and this keeps coming up. It's why I had you circle it a couple of days ago. All three angles add up to equal 180 degrees. So x plus 36 plus, and don't use your y, use the 36 here, plus 36 equals 180. Combine your like terms. Subtract 72 from both sides, and x equals 108. So we have a 108 degree angle there. Okay? Is there anything else that I want to do with angles? I don't think so. Let's talk about sides. Alright, let's go with, let's say that this is, ooh, we can do it that way. Nah, let's do it that way. Oh, yeah. some 42-degree angles here. And let's say that this is 18 and this is 3x plus 3. Okay, so let's stare at this problem for a second. I recognize that I've got two angles that are the same. If I have two angles that are the same, therefore, if I have two angles the same, then I have two sides that are the same. So if instead of giving you the sides, they give you the angles, that is the converse. Astute people will notice I'm writing something down again. The converse of the base angles theorem. I should move a bit so you can see that. I'm now realizing. So we have the converse of the base angles theorem, which is if the two angles are congruent, then we also have two sides are congruent as well. Okay? Also note that the base angles are not always the angles that are on the bottom. We frequently think of something like base angles as the angles that are on the base, on the bottom. But in this case, because the isosceles triangle has been rotated a little bit, my two base angles are no longer the two angles on the bottom. They are still the two angles that are not between the congruent sides. One really quick caveat before I solve this problem. Be really careful you don't see a situation like this, where they give you a 60, and two more, like they just gave you the two 60s. Say, oh, I got two base angles. Boom. Done. The reason I want you to be aware of that situation is because if you have two 60s, 60 plus 60 plus 60 is 180. So you don't have an isosceles triangle here. You have an equilateral triangle. So just be aware of that. Keep that in the back of your brain thoughts. If your two congruent angles are 60s, the third one's got to be 62 because it has to add up to 180. All right. Staring at this here problem. So they gave me the two angles, and from that I deduced that my two sides would also be congruent. When I have two things that are congruent, I can set their measures equal to each other. So 18 equals 3x plus 3, because these are my two congruent measurements. And then I solve, subtract 3 from both sides. 15 equals 3x. Divide by 3, 5 equals x. And you're good to go. I believe, what's my time at? 13 minutes? I'm running out of time anyway. I think that's everything that I really want to cover with isosceles and equilateral triangles. Remember, equilateral are also equiangular, but those go both ways. If you have the same sides, all three sides are the same, all three angles will be the same. And with isosceles, if you have two congruent sides, the opposite two angles will also be congruent, and that goes both ways. If you have two congruent angles, the two opposite sides will also be congruent. Homework 5.2 has been posted in Big Ideas for you. We will be moving on Friday, assuming that I see all of you then. Have a lovely day. Stay inside and good luck shoveling.